In this lecture, presented by www.free-academy.com, we're going to start our practice of the derivative products rule by doing problems 15 and 16 out of our text. Now, if you take a look at problem 15, and for problem 16 for that matter, neither of them are overly complicated. We could very easily distribute out all of our terms here, and then use our derivative products rules, our power rule, to find the derivatives. But especially if you look at problem 16, there's a lot of terms here. There's 3 in one, there's 2 in the other, and eventually we're going to start doing problems that have like 8, 9, 10 terms, and maybe trig functions and other things that we can't use the power rule for. So we need a more efficient technique, which is our product rule. Now, if you recall from the lecture from the product rule, the way we do this is by taking our two functions, or taking our function and split it up into two different functions, f and g. And the f of x is often just noted as f, and g of x is often noted as g. This is just a notation thing. And once we do this, the derivative of f times g is equal to f prime g plus g prime f. And it's completely arbitrary how we choose our functions here. We could have 3x plus 6f, 2x minus 1/4 to be g, or we can do it the other way around and call g is equal to 3x squared plus 6, and f is equal to 2x minus 1/4. But the goal is to pick things in the easiest possible way to get the problem done most efficiently. And often, whenever you have two things separated out by parentheses, you're going to want to use call f one parenthesis g the other parenthesis. Ultimately, we're going to start doing things too where we have 3 or 4 functions multiplied together, in which case we need to use the product rule several times in a row, but we'll get to that later. Anyways, for now, we've called f equal to 3x squared plus 6, and g is equal to 2x minus 1/4. To do our product rule, we're going to need f prime and g prime as well. So we need to find the derivative of f, and this is just a matter of using our power rule that we're already well familiar with at this point. And f prime is going to be equal to 6x. And the 6, of course, goes to 0 when you take the derivative of a constant. G prime is going to be equal to 2. Now, if these steps were too quick or too complicated for you, if you're not familiar with them, go back and check out our lectures on the power rule, where we've covered them. Anyways, now that we have f prime, g, and g prime, to find the derivative of f of x, we just simply need to plug things into our formula. So f prime is equal to 6x, and this is going to be times g, which is 2x minus 1/4. This will be plus g prime, which is 2, multiplied by f, which is 3x squared plus 6. And that is our derivative for problem 15. You can distribute out the terms if you like. You can take the derivative, we can go back to the original one, take the derivative by distributing things out, and you're going to show that if you do that route, or if you use the product rule, you're going to get the exact same thing in the end. Let's clear up a little bit of room here, and let's go and do problem 16. Now, for the same reason as before, we're going to call the first set of parentheses f and the second set g. And just like before, this is also completely arbitrary, but this is how we're going to go about it. F is equal to 2 minus x minus 3x to the third, and g is equal to 7 plus x to the fifth. Now we need to find our f prime, and we need to find our g prime. F prime is equal to the derivative of x, which is 0 minus 1 minus 9x squared, and g prime is going to be 0 plus 5x to the fourth. So to find f prime of x, we need f prime, which is minus 1 minus 9x, times g, which is 7 plus x to the fifth. This is plus, which I'll write down in this line here, g prime, 5x to the fourth, times f, 2 minus x minus 3x to the third. So f prime of x on one line is equal to negative 1 minus 9x times 7 plus x to the fifth plus 5x to the fourth times 2 minus x minus 3x to the third. And there you have the first two practice problems of the derivative product rule, and we're going to do plenty more.